How are you, my friends? This is another pre-calculus challenging question. If the range of the function f of x, 3 square root of 2 plus sine of 2x plus sine of pi over 2 minus 2x is m to n. Find the value of m times n. So first we have to look at the function carefully. And we see that there is the last term, sine pi over 2 minus 2x. We can change it to cosine of 2x. So we can use here the cofunction identity. The cofunction identity is sine pi over 2 minus theta is equal cosine of theta. Theta in this case is 2x. So sine pi over 2 minus 2x is cosine of x. Now the given function becomes 3 square root of 2 plus sine of 2x plus cosine of 2x. Now look at the last two terms here. Sine of 2x plus cosine of 2x. We can use reduction identity and leave for a minute this constant number here, 3 square root of 2. Just leave it. Let's take the last two terms. Now, if you forget the reduction identity, I can give you a quick review on the reduction identity. Reduction means we have sum of sines and cosines like this, a sine of x plus b cosine of the x. We can call a, as I mentioned here, the coefficient of sine of x, and b is the coefficient of cosine of x. So this expression is equal to k sine x plus phi. That's another angle. Now let's see, k will be the square root of a squared plus b squared, which is positive number and easy. Then the angle phi satisfies these two conditions. We have sine of phi b over the k and cosine of phi a over the k. We have to use both values here to decide about phi. Phi is in standard position, so it can be in quadrant 1, 2, 3, or 4. Let's go back to our question and use the reduction identity on the last two terms. So sine of 2x plus cosine of 2x, we can say capital A is the coefficient of sine, which is 1. Capital B also is 1 here. So I can find k, which is square root of 1 squared plus 1 squared. K will be square root of 2. Leave it now. Now let's find phi. Phi, we have to use sine of phi b over k, which is 1 over square root of 2. Cosine of the phi also a over k, which is 1 over square root of 2. That angle is pi over 4. It is in quadrant 1 because both are positive. Now just a note here, please. In this question, angle phi is not needed since the domain is required. But in other questions, you might need phi. Now the function becomes f of x 3 square root of 2 plus square root of 2, this is the k, sine 2x is the argument given there, plus the phi. Now let's see the final answer on this slide here. So the function now we have this one. To find the range, we have to use the formula from lecture 15, where we graphed the sine function. So the range will be d minus absolute value of a, d plus absolute value of a. D is the shifting. It is shifting up here, 3 square root of 2, because that's positive number. And a is square root of 2. So we can apply the formula for the range. 3 square root of 2 minus square root of 2, which is the a here. 3 square root of 2 plus square root of 2. Now, here you can subtract. This is like 3x minus x, 3x plus x. So it will be 2 square root of 2, 4 square root of 2. Now this is m and n. Let's multiply m and n. 2 square root of 2 times 4 square root of 2. 2 times 4 is 8, and this is 2. The answer is 16. Now for more questions on reduction identity, you can visit, please, the playlist, either extra pre-calculus solved questions on the reduction identity or the pre-calculus course lectures, 22 for reduction and lecture 15 for the range of the sine. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another pre-calculus challenging question. Thank you for listening.